Hello all, welcome again to Computer Graphics, a practical approach channel. If you didn't watch first two videos on curves and Bezier curves, please pause this video and first watch that videos. The link of that video is given in description. Now, in this video, we discuss about B-spline curves. We have already seen interpolation techniques to generate a smooth curve. It must pass through all sample points. It means the sum of blending function must be 1 for every sample points. For integer values of a, we may get blending function as a 1, but for fractional values of a, we may not be able to pass the curve through the sample points. Suppose there are 5 sample points and we may fix up to curve from this sample point as shown in figure. If the blending function is 1 for all values of a. So this is the 5 sample points as shown in figure, and we may fix up the curve from the sample points. If we see figure carefully, we will come to know that each section of the curve is connected to the other section of the curve at sample point. But the slope of two sections may be different, so we are getting corners in the curves. So we are getting the corners in the curves. It means the curve which we are getting is not smooth. In order to go near to the smoothness of the curve, we will pull the curve in such a way that the curve will be passed through the one sample point only. It means the blending function will be 1 for only one sample point. By using this technique, we may eliminate the sharp corners. But this will not give us a natural appearance of the curve. So here, we will not try to force the curve to pass through the sample points, but rather gently pull it into the neighborhood of the sample point. So by doing this, we will get a smooth curve which is not passing through any of the sample points, but still maintain the original shape of the curve. So as shown in a figure. So basically, in this, we will not force the curve to pass through the sample points. So by doing this, we will get the smooth curve which is not passing through any of the sample points, but still maintain the original shape of the curve. A set of blending functions which takes this approach is called B-splines. Basically, spline means a strip which we have to move around the sample points. Generally, the B-spline blending function were designed to eliminate sharp corners in the curve, and the curve does not usually pass through the sample points. But if we need sharp corners, we can produce it by using many identical sample points. So this is all about B-spline curves. Next, we will discuss the property of B-spline curves. The most important property of B-spline curve is the sum of the B-spline curve basic function for any parameter value u is 1, that is summation I equal to 1 to n plus 1 n I k of u equal to 1. Each basic function is positive or 0 for all parameter values, that is n I k greater than equal to 0. Except for the k equal to 1, each basis function has precisely one maximum values. The degree of B-spline's polynomial is independent of the number of vertices of the defining polygon. The maximum order of the curve is equal to the number of vertices defining polygon. B-splines allows local control over the curve surface because each vertex affects the shape of the curve only over a range of parameter value where its associated basic function is non-zero. So as we discussed in Bezier curve, the global control of points is used, but in B-spline curve, the local control of point is used. The advantage of is that when if we change the position of any point, that is any control point, then shape of the curve is not changed. So this is all about B-spline curves. Again, there is a different numbers of properties for the Bezier curve, that is the curve line within the convex hull of its defining polygon. The curve exhibits the variation diminution property, thus the curve does not oscillate about any straight line more often than its defining polygon. The curve generally follows the shape of defining polygon. All this. So this is the properties of B-spline curve. So enough for B-spline curves. Thank you for watching. Like this video, subscribe the channel. Once again, thank you. Good day.